Assalamualaikum warahmatullahi wabarakatuh. So today we are from group 2. We'll be presenting our group project, which is smartphone data analysis and IoT based visualization. This project, which is titled Smartphone Data Analytics and IoT based visualization. In this project, we explore smartphone specifications and pricing. We also utilize Python for analytics, including predictive models such as linear regression and decision tree. We also integrating ThinkSpot platform for the data visualization. This shows how traditional analytics can be enhanced with interactive insight. The problem statement that we have for this project is there are numerous of data sets available for examining smartphone specifications and performance. However, only a handful of them combine static data analytics with IoT-based visualization tools. Most data are statics, which limits their usefulness for dynamic monitoring, predictive modeling, and interactive decision assistance. As a result, there is a need for a system that can perform both predictive analysis of the smartphone pricing and also static visualization utilizing IoT frameworks to aid in intelligent decision making. Our objective for this project is to analyze exploratory and descriptive data. Also, we want to examine the feature correlations and their effects on pricing. We also want to emulate data telemetry by transferring specific data points to ThinkSpot platform. And we want to create predictive models such as linear regression and decision tree regressor. And lastly, we want to develop and deploy a customized IoT dashboard for data analytics. For system specifications, we utilize CSV dataset as our main data. CSV data is very compatible with the other tools that we are going to use in this project. Next, for the visualization and analysis, we utilize Python language and perform the analytics on Jupyter Notebook. As Jupyter Notebook is an easier medium to perform Python code comparing to others platform. Moving on to the machine learning model, linear regression and decision tree regressor is the best for this project. This is due to it giving the best result comparing to other machine learning model. And lastly, for the IoT integration, we are using ThinkSpot IoT. This is because the platform is the best in data visualization and making the data more interactive. Furthermore, the methodology on how we execute this project. First, we prepare the data by importing the smartphone dataset in CSV format using pandas in Jupyter Notebook. And then, we conduct analysis to understand the distribution and variability of features such as RAM, prices, battery capacity, and many more. And then, for data visualizations, functions such as matplot library and Seaborn are used to create histogram, scatter plot, bar chart, line chart, and pie chart. Moving on to the machine learning modeling, we implement two models which is linear regression and decision tree regressor. After that, we will evaluate the models by using mean absolute error, mean squared error, and R squared, which is coefficient of determination. And lastly, for the IoT integration, we utilize ThinkSpot for its amazing ability to visualize data. First, we will transmit the selected data to ThinkSpot Cloud using Python's request library and HTTP API. And then, we simulate data telemetry by sending JSON payloads with time delay. And finally, we create a custom dashboards with widgets such as bar chart, polar area chart, donut charts, and entity tables.
Okay, for the result part, This is the first part of the result, which is the descriptive analysis. So here's the table for descriptive analysis. So it featuring the pricing, rating, number of cores, processor speed, and so on. So it will measure the count, the mean, standard deviation, the minimum and maximum value, the percentile, and the modes. So as you can see here, there is a wide range of value for in terms of pricing, which referring to there is a diverse market for smartphone. And then there is also a constant value featuring the fast charging available, the number of front cameras, and the extended memory available. So it means that this is the common design choice for the smartphone specification. The next one will be the correlation analysis. So for this one, actually you can see the the RAM capacity. It has it has the positive value of correlation in terms of rating, which is 0.76, which means that user is satisfied with the smartphone. And then on the other hand, you can see the battery capacity there. It has negative value of correlation in terms of pricing and rating, which is negative 0.16 and negative 0.02. So it means that the user is not very satisfied with the smartphone spec. So for the heat map here, the heat map for correlation analysis, you can see the red color is referring to the positive value of correlation, and the blue one will be the negative value of the correlation. And then there is a white one here. The white one means that there is no correlation at all. So we can take a look at rating here. So this rating, you can see here is actually 0.8. So we can relate it to the 5G availability. So any smartphone that has 5G availability, it has higher a rating. And this one is, of course, the user is satisfied with the smartphone. And then you can see the blue one, which is the negative value of correlation. So we can relate this relationship between the rating and the here is the battery capacity. So it means that the increasing size of battery capacity actually tends to have a lower rating from the user, because people actually leaning more towards performance of the smartphone and the aesthetic look of them. Okay, here's the histogram for the distribution of the smartphone prices. We can see most of the smartphone is below 100,000 ringgit, and the count is actually dropping sharply as the prices increase. Second one will be the scatter plot for price versus battery capacity. So in this one, we can see that most of the smartphone that is below 100,000 ringgit tends to have the battery capacity between 2,500 and 5,000 mAh. And the highest pricing, which is above 600,000 ringgit, tends to have the lower battery capacity, which is below 2,500. Line plot for average price by number of CPU cores. So for this one, the highest average price, which is at above 80,000 ringgit, the smartphone tends to have six number of cores, and the smartphone that is below 20,000 ringgit average price will have four number of cores. And then here is the bar chart for average rating by brand. We can see the average rating that is higher than 80. We have brand called Lates, and the lower average rating, which is a shareable spot here. I think it is Leaf, TCL, and Cat Dawkins. The pie chart of percentage of smartphone with 5G support. Okay, for this one, we have a data set that is most of the model for the smartphone tends to have a 5G supported, which is 56%, and then 44% of them is not supported by 5G. And then here is the ML regression table. So in this table, we can see here the decision tree is actually outperform the linear regression, because we can see the value between the mean absolute error and the mean square error, which is decision tree has the lower value of it rather than the linear regression. and also there are square score. For the decision tree is positive value while the linear regression is negative value. So it means that the decision tree is much better than the linear regression. Also, we can see at the scatter plot for both of the linear regression and decision tree. So this scatter plot is actually based on the actual price versus the predicted price. You can see the dotted line here is actually the predicted price, and then here you can see the clearly that the decision tree scatter plot is mostly near the predicted line. So it means that it has more accurate predicted price rather than the linear regression. Okay, the next one is the decision tree model. So this model is actually used to predict the price of the smartphone. It featuring the processor speed, screen size, battery capacity, RAM capacity, internal and the internal memory. Okay, for the simulation part, I will show you how we actually transfer our data to the ThinkSpot. Okay, so this is our coding here. And then for this coding is actually actually in our data set, we have hundreds of model for the smartphone, but we choose the first five of the model, which is OnePlus 11, OnePlus Nord, Samsung Galaxy A14, Motorola, and the Realme 10. So each of these model actually we send the data, which is the brand name, model, price, battery capacity, RAM capacity, internal memory, processor speed, and the rating. Okay, you can see here I already run the coding and it shows here the output for each model. It says status 200. So it means that the data is successfully transferred to the ThinkSpot. Okay, this is our look for the ThinkSpot. So we use the ThinkSpot cloud, and here we have 5 devices for each model, and each model here it is in active state. So we also can double check the data it's sent to for each model here. Okay, so all of it has been sent. Okay, just to double confirm this one. All right. Okay, so to visualize this data, we actually create a dashboard called smartphone data. So in this dashboard, we create 5 widgets. First one will be the bar chart of the price. So for this pricing, we have OnePlus 11, that is above 50,000 ringgit. And then the lowest price is the Motorola, which is a little bit lower than the Samsung Galaxy A14. Second one will be the pie chart for internal memory for each smartphone. OnePlus 11 will have 36% here, and then we have the lowest one, Samsung Galaxy A14, which is 9%, and the others will have the same percentage, which is 18%. The third one is the donut chart of rating. So here the blue one is actually the Motorola, which has the rating of 81. The green one is OnePlus 11, 89, which is the higher rating. And then the OnePlus Nord also have 81, same as Motorola. And Realme is slightly higher, which is 82. And the Samsung Galaxy A14 is the lowest rating here, which is 75. And the fourth one is the polar area of processor speed for each model. So for the Motorola, we have two processor speed. The processor speed is 2, and then the OnePlus 11 will have 3, and then the OnePlus Nord is also the same as Motorola. The processor speed, which is 2, and then the Realme also the same, which is 3 as the OnePlus 11, and also the Samsung Galaxy A14 is also 2, which is the same as Motorola, OnePlus Nord, and the OnePlus Nord. Okay, so the total of the processor speed here is 13. And then the last one, it will be the entities table for the smartphone specification. So this table actually shows the specification for each model. So you can see here the OnePlus 11, each of the model here, we can see the brand name, rating, price, and capacity. battery capacity and in the internal memory. Okay, for the conclusion, this project successfully combined the data analytics with IoT integration for smartphone insights. We found key trends like RAM, memory, battery, the impact price, and the use of machine learning like decision tree and linear regression. And of course, clearly the decision tree outperformed the linear regression for the price prediction. The things for IoT enable interactive real-time visualization and it's proving how the IoT enhance the traditional analytics for smarter decision making. So that's all from us. Thank you.